Okay, we have a MacBook Pro. We actually have a couple of machines that we are of the same batch that we are working on. I think so far we have completed about four of them. I think so. So this is also one of the batch. So this is a 15 inches and it's a no power. And it says it's dead, no power. So and this is an A1990. I'm sure you guys can see that. Okay. Okay. So as usual, with no power devices, we are not going to connect power to it until we are sure of what state the device is in. Until we can confirm that it is safe to connect power to it, then we connect power to it. But then it's okay to try to power on the device to see if it turns on. But it's not advised to plug power to it because you're not sure what state the device is in. So first thing first, let's take out the back cover. If this is the first time you're doing this, you want to um, take note of your screws. They are not all of the same sizes. So the ones that I'm taking out now, they are going to be of the same size and they are going to be shorter compared to the ones that will be taken out from here. So two will be of the same size and then four will be of the same size. So the set of six screws, you have two of the same. So this and this two here, this two are going to be here and this four will be here. Okay, so screws are out and the back cover is out. So within 1990s, um, the first thing I want to do is I want to check to see if I will show it on my PB bus. And as you know, once you are when you're working on any device, the first thing you want to do is to disconnect, is to locate the battery and then disconnect the battery from the board. You don't want to have the board, you don't want to have power on your board while you're busy with it. You don't want to create more problems than what you already have on the machine. So the first thing you want to do, for example, this machine has two battery dual battery management to the board. You have the cable and the main battery power line. So we are going to disconnect the cable. And in 1990s are very common with the C9081 failing. So we are going to hope that this is also we've actually had about two, I think, of C9081 failing. So we're going to hope that this is also a C9081 issue because that makes the repair so easy. So in order to confirm if it's C9081 issue, we are going to measure on PV bus on the two fuses here to see if we have a short on PV bus. So we like to use this guy here because it is quite loud. Okay, so we are going to have it's confirmed that our multimeter. So that's it. So we're going to have our black probe on ground. We can use any of the cowlings for our ground, or we can use a screw hole for our ground. So and then our red probe, we just confirm that our probes are okay. So that's us measuring ground. Now let's see what we have on our PPOs. So we do not. So that it's not okay. 066. Okay, let's use diode mode to see if that's what you're supposed to get. Label. So with continuity multimeter, the value that I'm getting, I'm not so sure about that. So it says one. That's low, even though it doesn't beep. That is low. Nah. So okay. Let's use diode mode and see. So diode mode we have to use a red probe on ground and then black probe. Let's see what we get. Mm, nah, we have a problem on our baby as well. So that is low. So this is what I talk about when I say that even though you don't get to hear the beep, you still want to see what's happening. You want to look at the value that you get. I'm just going to get another board. So this is a board that works 100%, and diode mode measurement on this board. This is what we are supposed to get. So that is four something. That's 456 compared to that. So we do have a problem. And interestingly, I mean, if you use a continuity, continuity will not beep. So you may just get carried away and be like, okay, yeah, but because it didn't beep, then I'm not sure. But look at the figures. It's important that you see what figures that you are getting. And then if I check this one with the same thing, that is what we are getting. We're getting, let's see, we're getting, yeah. So we don't have a complete short to ground on this board, but we still have a short. So let's quickly take the board out. We are not sure where the short is going to come from. Let's quickly take the board out and see what we have. Our first stop is going to obviously be by C9081. We want to see if C9081 is starting to corrode, and then we then check other section of the board. So, but then first, our first stop is going to be by C9081. Okay, screws are out. Now we need a T8. Okay, that's it. Let's quickly disconnect our cables to get the board out of the shell. It's better to use your fingers wherever you can. If you need to use a tool, make sure you do not hand complete control to your tool. Okay, so taking our board out of the shell. So put the shell on the side. And again, before we finish, we are going to, okay, we can just do that now. It's just the inside of the machine. When you're dusting, also be careful not to break your any of the cables, especially the touch ID cable. Okay. Okay, let's just confirm again. See what is it that we have in diode mode. Red probe on ground, and then black probe 0 1 1 10. That's not supposed to be. That's a little low. So let's look at what C90. Okay, so that's C9081. So that that doesn't look too good. So what we are going to do is we are going to remove C9081 from the circuitry. Let's check again. No. So C9081, yeah, C9081 doesn't look great, but it's not our problem. So even if we didn't remove it, so chances of it failing was high. So now let's look around and see if anything else. So C9081 is out of the board. Let's see. Let's see if there's anything else that stands out. Okay, nothing really stands out. So let's just compare that again. Let's see what value we have still. Actually, that was our problem. C98, wait, C981 was our problem. But wait, why is it doing that? Do you know what? Let's actually let's plug power to it now and see if we have 12.6 on our PP bus, because my multimeter might just be playing with me now. I mean, okay, let's use continuity. Let's see what we get using our continuity mode, because we know what we were getting initially. So continuity, black group on ground, and then red probe. Now we still have a problem. That was exactly what we were getting. Um, that's interesting. Okay, but let us see. Let's connect power to it. Let's see what we have on PP bus. Switch to voltage mode. Yeah, we definitely do have a problem. Okay, so we will have to pick this up later because we have too many things to do. So we just have to come back to this board. Okay, yeah, we'll have to come back to that because also it's almost time for prayer. So yeah, we'll have to come back to this board. Okay, let's just be sure of the orientation. Okay, so pin one is going to be okay. So that we're going to do twice. First, we're going to press it down to even the balls underneath. Okay, and then the other side. So put those back. Okay, so the same thing we're going to do with this one. We will have to do it twice. So first thing first, we will press down on the chip so as to align the balls underneath. We are not going to worry about the orientation for now. We just want to try to see that. So now the balls are even. Now we can take it out. So now the balls are even. So that's the way we manually achieve reballing of the chips. So now let's look at the orientation. So we know pin 1 is supposed to be, let's see, okay, pin 1, okay, yeah, okay, so let's see. Okay, so that's that. The next thing we want to do is so now let's look around. So the good thing is we've now confirmed that we don't have a problem with U6550, U6500. We don't have a problem with that. We have confirmed that we also do not have a problem with U65, U6450, U6400. We don't have a problem on the side of the battery because the fuses are not present. So our possible issue, and definitely not on the side of the CPU, nor the side of the GPU here. So the next thing we want to look at now is let's see. So we want to look at, we've also confirmed that we don't have issues around the NAND because we did that by removing R5620. So the next thing we want to look at is the caps that are on the line. So at this point, we may have to inject voltage. That is, if nothing stands out. But let's just look again, just to see if anything will stand out. And then also, let's see. ROTC. Let's see what's happening by PPV ROTC, and let's see if we have a short on our ROTC line. So I want to see if we have a short on our ROTC line here. So red probe on ground, and then black probe. That's a bit low, I suppose. I'm not sure. I'm just going to confirm that. Uh, RTC, this guy here. Yeah, that is low. But I, I mean, you do need PP bus for the creation of RTC, and that's gonna be mm, wait. So what's happening here? So PPV in RTC is going to come from pin 5. So pin 1. Pin 1 is going to come from PPV in RTC on the other side. Uh, So it's going to come from this guy here, which is PP bus. So what you want to do is, so let us remove this guy. So that is R6900. That is where that's where voltage. That's where PP bus goes into the chip that regulates your RTC line. So we are now going to remove. So on one side, you have PB bus, which is made possible through R5440. So let's remove R6990 because R6900 because that would be the bridge between your PB bus and your PPV in RTC. So that's going to be on the other side of the board. So we'll flip the board to this side. Just want to confirm that we don't have issue. So it's going to be this guy here. So let's remove it and see what we get afterwards. Let's see what we have now. So we have our red probe on ground and then our black probe. Let's see what do we have on pin 1. One of the pin it's 1 something and then the other one. Okay, so that's interesting because let's see which pin is which. So this side, okay, so that is still PP bus. So this side is high and the other side is low. So we still have issue with the PV bus. So PV bus is this guy here. Okay, so our problem is still on the PV bus. So at this point, we are close to injecting voltage on the board. We're just going to try a little bit more before we do so. So our problem, our issue is not on the side of our TC. So let's put back that resistor. Okay, so resistor is put back. Okay, so PP bus. Let's go back to PP bus. So now we are now going to look closely at the caps. So while we are here, let us look at what. Okay, we are not going to be interested in R3441. No, we're going to be looking at. Let's see what this guy's. We're going to be taking a closer look at the caps now, and then here. But wait, we also have. Okay, but that's not populated. That's not populated. U95 of 80 is not populated. So let's look at this guy. This is sitting on the previous line, and it doesn't look. That doesn't look suspicious. That is fine. What else do we want to look at? Okay, let's look at these caps here. So these caps are going to be these guys here. So we are okay. This do not they don't really look like we have a problem there. Let's see, RTC. Okay, so but we don't have a choice. So what we want to do now is so before we come here, these guys are also not looking so good. They look a little swollen. I'm not sure if it's because of the heat that was in this section here. But let's see if we have PP bus in that region of the board. So the guys that look a little okay. These are 5 volt. So let's see what we have on our 5 volt line. 5 volt. What do we have there? 0271. Let's check on our working board. What do we have on that line? Yeah, that's about it. Okay, and then definitely PB bus. It's very low. So okay, so what we see that happen that's on the PB bus is going to be 123, which is going to be 123. Uh, so 123. We, mm, we don't see anything that really looks like a problem, but let's see. Okay, so let's start by taking those out. At least to know that we confirm we don't have a problem there. Uh, we're also going to remove we're also going to remove C6582. So C6582, that will have to go. Just to be sure that none of the big cap are having issue. Okay, so let's check, see if we have anything different. Red probe on ground, black probe on this side. Yeah, zero, that should be ground, and then on the main, nah, it's dropping. Yeah, it's dropping. No, we still have a problem there. Yeah, we definitely still have a problem. Let's see. 180, is it increasing or decreasing? 190, 87. Nah, it's decreasing. We still have a problem. We still have a problem. Uh, yeah, we still have a problem. So let's put those back. You have to understand that these are polarized caps. When you're putting them back, be aware of the markings on the cap, which will indicate what goes to ground and what goes onto the main line. Okay, now we are now going to go to the other side of the board, which is this side here, to remove the caps and also to see if that is a problem. And if we still don't find our problem, then we'll have to inject voltage. Okay, so it's sure. Okay, so these are the guys that we're going to remove. It's still here, so about six of them in total. Okay. 220, 230. Is that increase? Yeah, it's increasing. Alhamdulillah, that looks good. It's increasing. So, okay, I think we found our problem. So it's one of those guys. Okay, alhamdulillah, that's good. I think we found our problem. So it's one of those caps there. What we now want to do is we are not just going to replace all of the caps. We are going to find out which of the cap has failed. So we are going to try to read across. Let's see. So depending on the numbers that we get, that will determine which has failed. Uh, uh-uh. Now we're not going to be able to read that one. Okay, nonetheless, let's see what is the one. Okay, so we're going to use a continuity mode for this one to read the capacitors. So we'll put on both sides, what do we have? We're looking to have OL, which is fine. Yeah, that's good. That cap, it's fine. That it's fine. Remember the way capacitors are designed is such that pin and both sides are separated by a form of insulation material. So the material in between prevents the both sides from being equal. However, when it fails, then you will either find that the both sides will either be completely equal or partially equal. So that is what we're trying to establish now. And that is our problem. Now you see the interesting part of it. So the cap itself, it's not zero ohm across. So the cap itself, so it's not zero, which is why we were not. So you see, it's not beeping. So the cap itself is it has not completely failed, but then we have um, you know, yeah. So 573. So the cap itself has not completely failed, but it's enough to prevent the device. It's enough to prevent the device from starting. So and then this guy. So we're hoping that is the only one that had failed. No, it's not the only one. So that's another one. Two, okay. And you? Okay, so let's just be sure. Okay, so this three are fine. These two are not. And I mean, unfortunately, we're not able to measure this because the other part is gone. So this I'm gonna. So we are gonna reuse those. Uh, get another board to get those from. Okay, let's just leave that and place. If I wasn't doing a direct transfer, I will have to be aware of the orientation. So be aware that these are polarized capacitors. So you have to make sure you orient them the right way. Usually they'll put a marking on the main line, and so that would symbolize what the voltage line. So you can identify the voltage line from ground. Okay, so let's do a bit of a recap to how we found ourselves here. Oh yeah, we need to put back the fuses. The fuses, they have no polarity, so you can place them however you want. So you don't have to worry about how you place the fuse. Both sides are equal. Okay, so this is yeah. Let's go back to let's do a recap. This is only 1990. It's very common for PB bus failure, and then when PB bus fails, the easy go-to section will be C90, C9081, because that's one of the commonest caps I feel on this board. And as a matter of fact, even though the cap was not our problem here, the cap was still not looking okay. So we had to remove the cap, which is something that I always say, that even though you are not working on the section of U98, C9081, even though it has not failed, but it's best to remove it as a preventive measure. Okay, so I mean, from the look of it, we had a short on PB box, and it was not on C9081. So what we then started to do was, so we had two options. Option A is to inject voltage on the line, and then option B is to manually remove or manually cut out the bridges between the main PB bus line and the subrails of the PB bus. So we did that starting from the section of the NAND. We removed the current sensing resistor for the NAND. That was not a problem. We removed the current sensing resistor for the GPU. That was not a problem. We removed that of the CPU. That was not a problem. We removed the amp ICs for the speakers. That was not a problem. We tried to also separate the issue from our TC line, and finally we found our problem to be one of these caps here. So these guys, so these are the guys. So one of, actually not one, two of the caps actually failed here. And we were not able to measure the other one because the pad was off. So one interesting thing here, you saw how when you measure, because this is I'm just gonna show you something. So a complete shot is going to look like this. So a complete shot will look like this. You hear a beep, but in this case, we are not getting a complete short, but we have a problem still, which is why I say whenever you're using your continuity mode for your measurements, even though you don't hear the expected beep, look at the figures that you're getting. Okay, so right now let's see what we have on our PV bus. We're hoping that we should have a working board now. So let's check again. Red probe on ground using diode mode measurement, and then a black probe. And that's exactly what we want to have. So now let's connect power to our board. We are expecting to have 12.6. Hopefully, if the circuitry is working the way it should, we should be getting 12.6 and a half PB bus. Hmm. 0 volt on PB bus. Did we just get another shot again? Okay. The charger is definitely working, so let's try that again. Okay, looks like we still have more repair to do. So we're getting less than, okay, so let's see. Let's check. Did it suddenly fail again? Continuity. Yeah, let's see. Did it fail again? Isn't that interesting? Did it just fail again? Wait, what happened? Did something burn out? Okay, so let's see. Did PV bus just burn out again? Okay, that's interesting. Let's go back to those caps. Remove them. We know we did this two here were part of these two here were part of the old ones. So let's remove the two. So that was those two were part of the ones that came from the board before. So let's remove those and see. Mm, interesting. Okay, red probe on ground and then black probe. No, this is not our problem. That's very interesting. Okay, so let's remove the entire cap. We started from there because that was where we had issues before that region. So wait, I hope we're not missing the caps. So this has to be that side. This the yeah. Okay. Yeah, diode mode. So where is the problem now? We have to start it all over again. So the problem is you have to start all over again. Okay. Okay, so let's put those caps back. Okay, we have to start all over again. Trying to get the markings. Okay, what we want to do is we're gonna give just allow the board to cool off a little bit. We are going to connect power to it, and we hoping that whatever it is that is now shorted now, even though we have previously resolved it. Wait, that doesn't look good. That doesn't look good. Is that on the PP bus line? Let's see if that's on the PP bus rail. That cap doesn't look good. Uh, this one here. Yeah, that's on a PP bus. That's on PP bus. So let's remove that cap. And then let's check again. Nah, that's not that problem. Okay. Hmm. Interesting. Okay. Did we do something? Okay, so we're going to connect power to it and see if anything gets warm around the PP bus rail before we go over the same thing. I mean, we okay, let's start from the side. So the idea is otherwise we'll have to. But this time I'm thinking we just instead of having to go do the same thing again, we might just have to inject voltage. That will save us time. Mm. And then also what we say is we getting exactly the same type of short that we had initially had. Is actually lower now. Okay, yeah, we see that around about the same thing. It's exactly the same thing. Okay, so initially we took out these caps here, and our problem was one of these caps. So what now? Where? Okay, so at this point, we are going to inject voltage because uh, Otherwise, instead of having to go through the same thing again, taking out caps one by one, so we'll have to let's just confirm that most likely that's a problem is not even there. So yeah, PP was is here, and the battery side it's fine. Okay. Mm, mm. So we inject voltage. I think at this point, yeah, we just have to inject voltage. So the idea is we inject voltage on the line, and then whatever component that is connected to ground will get warm. Okay. So the idea is we are going to inject voltage on the line, and then whatever it is that is causing our problem should get warm. So we're using a power supply, and then we gradually increase it. Let's see. Let's see, what is it that we have on our book? Let's just see. What are we getting in PP bus? 5 volt. That's interesting because 5 volt would mean that there is no short on the line, because that's exactly what our power supply is pulling out. Is this, okay. Uh, let's check again, because let's check to see if we still have a short on the line. Interesting. Putting 5 volt on the line, and then we're getting 5 volt. So, which would mean that we don't have a short on the line anymore. But let's confirm that. This is Joe. So, do you have a short or you don't have a short? So, okay, let's put back fuse. This is supposed to be our ground, and then that's our PBMOS line. Okay, so for some reason, short seem to have disappeared. Um, okay, okay. Let's connect charger back to the board. See what we get. Switch to voltage mode. Now we have 12.6. This is very interesting. Okay, so 12.6 would mean that the board is actually trying to start. This is very confusing because the problem that we found in the board was a failed cap. We replaced the two caps, and we put the components that we took off back, and decided to have exactly the same short that we had in the beginning. And then we decided to inject voltage because that way we can see what gets hot. And then we injected voltage, and then we push it up to 4 5 something volt, about five point something volt, and we were getting exactly what we're pushing up from power supply on the board, which would mean that none of that power is going to ground, which means there's no short anymore to ground. And then we'd be like, okay, yeah, but there was a short before the injection of power, but now we don't seem to have one. We disconnected that, put back the fuses, and then connect power to it, and the short seemed to be gone, and the board seemed to be working. So let's just try that again. Yeah, interesting board. And let's see what we measure. 2.6. Okay, that's beautiful. So let's see if the board actually works. Let's put the board in the shell. Okay, we're going to connect only the cables that we require for the testing because we still have to clean the board. Screen cable, we'll need that. This is jack. We need that. We need the speakers to give us a nice loud dong. And also we need the speakers to confirm if the filters are properly replaced. Remember we had to replace the filter, so we need the speaker to confirm that. We can just add our battery screw. Even though we don't need that to get the device to power on. Okay. Chargers connected. So we have trackpad feedback. Yes, we have trackpad feedback. Do we have anything on the screen? That's a beautiful dong. Expected to see an Apple logo. This is going to be one of those ones where we have issues with power and backlight. Interesting. We might be having the same thing. We might be having issue with backlight as well. Uh, is the screen connected? Okay. I don't see nothing. Is the screen connected? Okay, let's shut it down and try again, see if we pick up anything. Oh yeah, the power button is not connected. Okay, so let's just disconnect the battery. Let's also make sure that the screen is properly connected. The screen was connected. So let's okay. See if we pick up anything. I don't pick up nothing. It's interesting. So I don't pick up nothing, which suggests it's not an issue of backlight. Okay, so yeah, let's see. What do we have in our backlight output? Backlight output. It's okay. That's interesting because backlight output it's full, which would mean that the screen is not consuming what the machine is producing. 49 volt will mean that the screen is not consuming what the screen is not consuming whatever the backlight whatever that is being generated on the backlight line. Interesting. Okay, okay, so okay, let's do this. Is our screen not properly connected or what? Let's try that again. So if you get the exact voltage, so let's try again. I think we should do a PRM reset if it still doesn't work. Yeah, so let's see what we have on our backend output. 48. Okay. Okay, let's do a PRM reset. Oh wait, what am I doing? It's not connected. Okay, so let's do a PR reset. So our backlight circuitry, it's doing just fine because it's doing its job, but the boosted voltage that's been generated from our backlight, it's not being consumed by the screen. So we want to do a PR reset to see why that is the case. So hopefully that will fix it. And we still have, oh no, our screen is cracked. Can you see that? There's actually, yeah, screen is damaged. So just, okay. Uh, okay, so, oh yeah, I see it also here. Can you see that? The screen is broken from here, yeah. You see that? Yeah, the screen is broken. Okay, so it's actually okay, yeah. So let's see that. So the reason why wait, what is that? For the did we get? Okay, yeah. So screen it's yeah, screen is fine. So yeah, we have a working device. We have a cracked screen on it, so that's something that the company will have to worry about. But on our side, the repair is complete. We are now going to clean the board and assemble it. And I'm not going to add that to the video because it's not going to become too long. And yeah, thank you guys. I will see you guys in the next one.